Alright, so in today's video, we're going to talk about the volume, right, and what volume is and why it's important to understand, right? Volume is a geometric idea, okay? The volume talks about how much space is in a three-dimensional object, right? So let me write that down. The volume of something, when we talk about volume, what we're talking about is that we're talking about the space within a three-dimensional object. For example, like a box, for example, like a can, for example, like a tub, things like that, right? Volume is different from perimeter and area. We had talked about in a previous video that the perimeter of an object is the space within, it's the distance around an object, right? So if we say something like the perimeter of something, right? What we're talking about is the distance around it, right? For example, like a park, right? If you are jogging around the park, if you're jogging around the park, then if you jog around the entire park, then you jogged around the perimeter of the park, right? The area of something is the space within. The area of an object is the space within the object itself, right? So again, using the example with a park, for example, we will say that if, you know, the space where the trees, the space where the swings, the space where all that stuff is located within the park, and that is located within the area of the park, right? The swings, the slide, the zoo, whatever, right? The thing about perimeter and area is that perimeter and area is talking about a two-dimensional object, right? So, or because it's talking about a situation where something is on a flat surface, right? For example, like a table, for example, right? You can find the area of a table because the area of a table, depending on how it's shaped, can be either a square or a rectangle or whatever, right? Same thing with perimeter. It's talking about a two-dimensional object, right? It's talking about on a flat surface, right? Like, for example, paper, for example, would be an example of a two-dimensional object because because it doesn't have height, right? But the volume of something is different. The volume of something is talking about the space that can be filled within a three-dimensional object. What volume takes into account height. It takes into account height. So, for example, if you're talking about, for example, you want the volume, you need to figure out the volume of, a box, the volume of a suitcase, the volume of, a can of soda, something like that. Because the point of volume is that it takes into account that third dimension, which is height. Perimeter and area only takes into account length and width. Okay, so that's that. Okay, now we can calculate volume, right, depending on how the object is shaped. So, for example, the volume of a cube, for example, right? This is a cube, right? Notice that a cube looks like a little box, right? The volume of a cube is the length times the width times the height, right? So, for example, say we have a little box, right? And we say, okay, well, the box is 6 inches, the length is 6 inches, the width is 8 inches, and the height is 4 inches, right? And we want to know what is the volume of the box. So then we would say, okay, well, what is 6 times 8 times 4, right? 8 times 4 is 32. 32 times 6 is 192, right? So the volume will be 192 cubic inches. Okay, it's 192 cubic inches. Volume uses cubic, unlike with area, which is you use square units. Volume uses cubic units because it's talking about a three-dimensional space, right? So we use cubic units, okay? That's for the volume of a cube. The volume of a rectangular prism right? Rectangular prism looks something like this, right? Something like this, more or less, right? Is also the length times the width times the height, okay? So for example, if the volume is like, let's say the length is 20 feet, the width is 18 feet, and the height is 9 feet, and we want to know what is the volume of this thing, then we will say, well, 20 times 18 times 9, right? So 18 times 9 is 72, which is 162, times 20, which is 4, 2, 1, right? So we know that the volume, 4, 2, 1, we know that the volume is 3,240 cubic feet, okay? All right, the volume of a rectangular prism. The volume of a rectangular prism, in practice, in a practical sense, is used when you want to figure out certain things, like if you want to figure out, which we'll talk about in a later video, like if you want to talk about like how much water can fill a swimming pool, or yeah, how much water can fill a swimming pool, because remember, a swimming pool is a rectangle. Usually, usually depending on how it's shaped, it's a rectangular prism, like one of those standard pools, right? So it depends, but some of the applied problems that deal with a rectangular prism, right? Okay, next one. We have the volume of a cylinder, right? The volume of a cylinder is pi r squared times the height, right? And the cylinder looks something like a can of soda, right? It looks something like this, more or less, right? Looks something like this, right? And we want to know the volume of the cylinder. The reason why the volume of the cylinder is pi r squared is because, right, without going into advanced, math, it's because the bottom of the thing is a circle, and we have this little thing here, which is the height, right? This is the height. This is the area of a circle, right? So that's why it's pi r squared times height in a simple sense, right? So basically, say, for example, we want to find the volume, and let's say the radius is, let's say it's 8 inches, and let's say the height is 4 inches, and we want to know what is the volume, right? So if we know what the volume is, then we know that, okay, pi, right, a squared times the height, right, which is 4. So we know that, right, a squared is 64 times 4 times pi. So we do 64 times 4, 64 times 4, which is 240 over 16, which is 256 pi. So this becomes 256 pi. I'm not going to go into the approximation of pi because it's not necessary, right? So we just put it as the volume is 256 pi, okay? This is the volume of a cylinder. An example or practical sense of the volume of a cylinder would be like the volume of a can of soda. The volume of a can of soda, the volume of a bottle of soda. What's another example? the volume of a cup, so on and so forth, right? Okay. We have the volume of a sphere. Okay. So a sphere is like a little basketball, right? I don't know how to, it's kind of hard to draw, but basically, you know, we have this little basketball looking thing, right? Something more or less like this, right? And the volume of a sphere is 4 over 3 pi r3, right? Now, the reasoning for why this is, you will learn about it in a higher course, but basically, for the purposes of this video, you just have to memorize it for what it is, right? The volume is 4 over 3 pi r cubed, right? So basically, what you want to know is that the radius is, let's say the radius is 4 inches, and we want to know what is the volume, right? So we know that 4 over 3 pi, 4 over 3, right? And we want to know, okay, 4 over 3 pi, 4 times 4 times 4 is 64, right? Because 4 to the third is 4 times 4 times 4. This is 16 times 4, which is 64, right? So it becomes 64. Now we do it, right? So we say, okay, well, what is 4 third times 64 times pi? This becomes 64 over 4 is 240 over 16, which is 256. So this becomes 56 over 3 times pi, right? Which is, we want to just leave it as a fraction, right? Which is 256 over 3 times pi, okay? The volume of a sphere usually deals with, in a practical sense, we usually deal with things like if you want to figure out how much air do you want to put in a basketball. Things that are sphere-like are like things like a basketball, things like the planets, because most planets are spherical in nature, right? If you don't figure out what is the volume of the Earth, what is the volume of the Moon, what is the volume of the Sun, right? Usually things like that, right? In a practical sense, depending on, you know, what are you trying to use the information for, right? So again, to recap, we have, I used 4 examples, right? 4 examples of volume, right? The first example that I used is the volume of a cube. The volume of a cube is length times width times height. The volume of a rectangular prism. The volume of a rectangular prism is also length times width times height. Okay. I talked about the volume of a cylinder. The volume of a cylinder is pi r squared times the height. And I talked about the volume of a sphere, and the volume of a sphere is 4 over 3 pi r third. But I mentioned that when you do the volume of a sphere, you just have to memorize it for what it is, because the proof of it is, you know, you won't really understand it until you get to a higher level, right? So that's that, right? In a practical sense, like I already mentioned, when you know, practical applications of the volume of a cube would be like if you're talking about, like you want to figure out how much space is in a box, for example, you do volume of a cube, right? If you want to talk about a practical sense of rectangular prism, it would be something like if you want to figure out how much space is in a swimming pool so that we can fill it with water, right? That would be an example of a practical example of why we have to learn volume of a rectangular prism, right? Because depending on how the swimming pool is shaped, we don't know how much water needs to be put into it until we know the volume, right? Volume of a cylinder. An example of a volume of a cylinder would be something like, you know, how much soda, well, it would be something like, what is the volume of the can so that we know how much soda we can put into the can, right? How much would it cost to put the amount of soda in a can, right? That would be an example of the volume of a cylinder, right? And the volume of a sphere, a practical sense of volume of a sphere would be something like if, you know, you wanted to know something, you know, like something like the volume, like how much air would you need to put into a basketball, or like what is the volume of the Earth for some like scientific purpose, right? It depends. It depends on like what you're using it for, right? So that's that. So that's it for today. We'll go into more applications of volume in a next video, but basically you just want to understand that the volume is a space within a three-dimensional object, and that it is distinct from perimeter and area, because the perimeter of something is the distance around it. The area is the space, is the little space within the object. This is area. It's a space within it. And that perimeter and area talks about a two-dimensional flat surface as opposed to volume, because volume talks about a three-dimensional object, because it includes height. It includes height. Okay, so that's that. Thank you and have a nice day. Bye bye.